So I'm in the process of migrating from one storage unit to another. To save some money, my current storage unit's gotten super expensive. And as I was moving stuff, I came across this little floppy drive. And I know I've had this for a while. I don't know where I got it. The 0 written like this on the side and the red grease pencil tends to indicate it came from a local recycler here in the Seattle area. It's a little ZFW 3.5-inch floppy drive unit. Obviously that's what it says. It's got drive G and H, stickers on it, and they are little stickers. Searching online, the only references I see to this are in Japan. So maybe it went to some Japanese computer. I don't know. On the back, there's what appears to be a 50-pin SCSI connector. I don't know if it actually is SCSI or not. It might just be a SCSI connector used for floppy signaling. I don't know. There's a power connector here because I'm seeing references for this in Japan. I'm assuming that's probably 100 volt AC and not the US 120 volt. But hopefully we'll find out. So I've never opened this guy up. I think I'm going to here. The little MD logo down here is interesting. So 3.5-inch floppy disk drive unit. MD, that just seems familiar, but I'm not sure for what. So let's go ahead and back the screws out and see if we can figure out what we've got here. Hopefully I'm on camera. Hopefully this little screwdriver will be sufficient to break these loose. I hate it when they're so tight. I need to pull out a larger screwdriver. They don't need to be that tight. Apologies for the mess around me on the bench. There's a whole bunch of projects going on. That I'm ping-ponging between as I access parts and stuff. These little feet are interesting in that they can be rotated. And they obviously can snap together. But if I was to take a drive unit like this and snap this on top of it, it would be offset back by, I don't know, the whole thing is just weird. Will that slide out, or do these need to come out as well? I'm suspecting, based on how tight that is, that these need to be backed out as well. They do. So that's interesting that there's 8 screws to hold that metal shell in place. I've done a Google search here. There's a few of these showing up on various Japanese sites, where you bid on things, kind of their equivalent of eBay. So that gets that much of the cover off. Wait, is there actually a SCSI adapter here? I don't see a large enough dip, in my opinion, unless that guy there is. Huh. Interesting. So, it looks like to remove this board, I need to pull the screws out here out, which makes sense. These become the strain relief for that 50-pin connector. It took quite a bit to back out as it is machined, threaded at least. Of course, this one's coming out looser because the whole thing is shifted. I suspect we'll find out. Thinking the spring clips will need to come off, but we'll find out. Looks like there's 2 screws to hold this printed circuit board in place. Those look to be the same screws that were the case screws. This one was actually loose on its own, which is interesting. Can I get you to pull back? I can. Yeah, I'm going to have to, I think, remove those. Need a pair of needle nose that are up for this task. Usually these are just spring-loaded and can be popped out fairly easily, but maybe not. Huh. Well, there's a floppy, what looks a lot like a 34-pin floppy cable to me underneath the board here that I've just worked loose. Midori. That might be a good clue what this is. MD233 floppy disk board. I only see a subset of pins that are used. There may be ground along this entire backside. I don't think that's SCSI, honestly. Although there's enough logic here. I don't know. It's pretty much regular TTL logic. Looking for a date code. 12th week of 87. That gets us a pretty good date code. It's labeled 34 pins, so it is looks to be a standard 34 pin connector. There's a little tiny switching power supply down in there. I'll have to do some more searching here. So apologies for being off screen here. Let me search for what we found on the board. MIDORI, FD-board, ARD, space MD-223. See what we come up with. It hit on MD is what most of the again, really nothing useful in that quick search. There's an LED connector that is polarized. There is what looks like it must be 5 volts coming up to the board, which again is polarized, so I feel safe pulling it off. I seriously doubt I'm going to find information on that part number. It's just regular TTL logic besides that. Just nothing special there. Let's go ahead and pull the front off of it at this point. Looks to be the same screws again. No surprise, you would standardize as much as you could on screws. Oh, that one's shorter. Is that shorter for a reason? These are definitely different here because they are flush. There's a name for these. What is the name for those? They go into a countersunk hole. Let's disconnect the power switch. Nothing special there. The short one. Not sure why there was a short screw there. There's nothing for it to hit up against. So maybe this has been apart and together and that's just what somebody put on it. That is a really standard 1-to-1 floppy cable. There's just nothing unique there. Nothing at all unique. It's not odd. That connector will be a bear to get out of there. The power connectors look to be standard floppy power connectors. There looks to be a little card cage, or not card cage, drive cage for each. So there's a, I guess potentially, I don't know if that's 5 1/4 inch width or not. These are the shorter versions of the screws. Are we going to find a long screw driven into one of these holes? The shorter versions make sense here since we are driving. Well, they don't because we're not driving into the drive mechanism at all. But we will keep those separate. I was just noticing on the switching power supply the diodes are very high up off the board. Well, look at that. And that was done obviously for heat dissipation. So that little tiny switching power supply in there is probably being taxed with both drives operating potentially. I suspect that will release the thank you for that. The eject buttons fell off of both drives. See if I can get the connectors off. I hate pulling these by the cable. There's just not much choice in how little room there is in there. Boy, that looks like a standard FD235GF. That is a standard in my mind TEAC, and it is a TEAC floppy drive. It can be jumpered for drive 0, 1, 2, or 3. That kind of gives us a hint of the date. Is it a 720K or a 1.44 meg drive? There's a couple different head load options. Let me go ahead and look it up. It's nice having this laptop on the desk here. So it's an, let's see, it's an FD235GF. FD235GF. It found a PDF. FD235 series. So let's see, the FD235GF is 1.6 megabyte / 1 megabyte. So it is a high density drive. The 235HF is a 2 megabyte, or no, it's not. Is this a 1.44 meg drive? This always confuses me. The 235F is 1 megabyte. The 235G is 1.6 megabyte / 1 megabyte. So that is 720 and 1.44. The HF is 2 megabyte, 1 megabyte. And the HG is the 2, 1, and the 720. So this is a standard 720 / 1.44 meg drive. Nothing really unique about it. This one's set on drive select 1. I suspect this one will be set on drive select 0. Did I not get all the screws out? Oh, there's a couple of, that was interesting. I don't know if you saw that or not. There's a couple little dimples here on this bottom one. And there's some dimples here in the sheet metal for this drive. They kind of hold it in place when it's in the right spot. That's interesting. Yeah, this one's on drive select 0. It's the same drive. So this is just a pair of 1.44 / 720K floppy drives in a little micro case. I mean, it's really slick. That's really cool. Potentially useful. I talked about the diodes earlier. There are 2 diodes here. Hopefully they're both in focus. You can see them. They are 3/4 of an inch probably up off the board. That's got to do with getting good airflow around them for circulation. You can see that there's a vent here on the bottom, which would be the bottom of the drive, and there's a back vent, and that creates airflow over the power supply. So the warm air rises, vents out the back. It's passively cooled. There's no fan. There is a metal plate with the power supply mounted to it, and that's what the 4 screws down here are. ACN 100 volt, 50 to 60 hertz. So it is a 100 volt switcher. It's got to produce +5 only. If I was going to use this in the US, I need to replace that little switcher with a 120 volt capable switcher, and I'd really want to swap this out for an IEC connector. So we had ground as well. So I really can't power this up in the US, or I shouldn't, just because we're dropping 20% more voltage or more into it than we should be. +5 at 1.5 amps. So is that +5 at 1.5 to 2? +5. That's an interesting marking. +5 DC, 1.5 somethings, or 2 amp. Okay, in English it's 2 amp. I see what they've done. Tamura Corporation. Don't they make model kits? I swear I've built a few Tamura model kits in my time. Maybe not. So, again, nothing really unusual here. It's just looks like a pretty standard switcher for back in the day. A little adjustment here, potentiometer, I'm sure, for the 5 volts. Heat dissipation wasn't mounted up as high as they are. You can see by how dark the leads are that I think those have been really warm. The leads are actually bent to create this offset standing up off the board. Oops, anything else to comment on here? You know, there's just nothing particularly special about this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 and 17 is 34, which means this is just a standard floppy connector here, and it just happened to use a 50-pin cable, or a 50-pin connector here, so a SCSI looking cable. Why there's all this logic? I guess that's to create additional offsets to push this up to drive G and H, perhaps. There's no jumpers here, however. I wonder how it was configured. Or maybe it's just permanently wired to be those drives. It's interesting. There's this much logic on it, so it makes me wonder what they were doing with the floppy controller. I'm sure I won't find this NEC chip, but I'll go ahead and do a search while we're on line here. NEC, or while we're recording, D71 space D71 066. Well, I see an 066C called out, so well, that's certainly not what we're looking for. That is a low, is a diode, low standard recovery diode. So the part number that came up, D71066, D71066C. I'm sure that's a house marking or not. Yeah, there's nothing. Standard recovery diodes, low power diodes, there's just nothing here that is this particular part. No surprise. It's even a non-standard lead pitch. Where these guys are 0.1, that's that 0.7 or whatever the heck it is. It's interesting, there's even two crystals on the thing, a 16 megahertz. That might be some kind of little microcontroller. I just don't know. Why is this adapter so complex? It must mean that whatever was on the other side of the cable was less complex. Anyhow, there's two LEDs here. So there's just a single panel here, I guess, that glows, with two LEDs behind it that are rather crooked. Does it go this way? It goes that way. Okay. Yeah, they line up now a little better that I did some straightening on them. Anything else to say here about this? I don't think so. It looks like this little back cover, spot welded on, I believe. Anything else here to look at? I don't think so. I guess I'll just add a couple comments. This could be pretty easily converted to just a dual 3.5-inch external set of floppy drives. This might be like really useful on one of my CPM machines, maybe. I could just bring a floppy cable directly out the back and not even use the board, just a long cable. There's nothing, like I say, special about that cable. There's nothing special about the drives. Not much else to say here. I guess I'll put it back together, and I'll see you in a future video.